So, good afternoon to everyone and welcome back to the class on tribology. So, now stage is back to you guys for your presentation related to the OBE activity on our subject tribology. I think the first group is Gautam Krishna and his team. So, over to you. You people can now start with the presentation.
Yes,
Good
ma'am.
afternoon, ma'am. Our topic today is importance of lubricants and its field of applications.
Yours
Our
is
group
team
consists of
one.
yes, ma'am.
Okay.
Group consists of myself, Gautam, Akram, Chaitanya, Ishant, and Shri Prasad.
Okay.
Next.
So should I start again?
Yeah.
Gautam, Ishan, can you start over again?
Yeah.
Ma'am, there's a lot of disturbance coming from your end, ma'am.
No one is there, my dear, here. Okay, let me.
Start, Ishant.
We'll wait for ma'am to come back. Wait.
You please start. I've just muted my mic. You
Okay,
please
sorry.
start.
Yes, sorry,
Yeah.
ma'am, sorry.
Yes, ma'am.
Good afternoon, ma'am. Our topic is importance of lubricants and its field of application. Our group consists of myself, Gautam, Akram, Chaitanya, Ishant, and Shri Prasad. Yeah, Ishant next. So, first of all, what is lubricant? It is a substance, usually organic, introduced to reduce friction and wear between two mating surfaces. It also has other functions such as transmitting forces, heat absorption, etc. And lubrication is a process or technique in which we use a lubricant to reduce the friction and wear. Yeah, Ishan next. So coming to the importance of lubrication, first one is reduce friction. So first of all, friction occurs when two surfaces with asperities collide. The small surface area of the asperity along with the load of the mating surfaces create extremely high loads and they resist the moment. So this is called friction. And in order to reduce this friction, we use a lubricant. So when there's a lubricant film present between two surfaces, as one surface slides over the other, the lubricant gets sheared off, and there'll be free movement, and there'll be no friction or very less friction. Next, Ishant.
Yeah. So as we know that when two surfaces interact with each other at high speeds, they are bound to wear, and this causes very small particles such as asperites to be formed on the surfaces that are formed when they are subjected to cutting, tear, fatigue, and weld. So what happens is this surface to surface mode occurs at a microscopic level, and at this level, at like when at high speeds, the asperites wear off the top layer of the surfaces of the moving parts. So we use a lubricant so that the wear is reduced, and there is like the longer period, like the period of the wear, or is like the period of the parts moving parts is prolonged.
Remove heat. Lubrication reduces the heat generated when two surfaces are in motion. It smooths the process by forming a film between two surfaces, thus reducing the friction and also improving the performance and efficiency.
Okay. To remove contaminants, lubricants are used as circulation system which have benefits of carrying away the internally generated debris and external contaminants that get you introduced into the system to a filter where they can be removed. So lubricants for machine that regularly generates debris or contaminants such as automotive engines. They typically contain detergent and dispersion additives to assist in debris and contaminant removal.
Ma'am, some in some moving parts you have a high concentration of chemicals. So these concentrated chemicals they usually cause corrosion. So to prevent corrosion over here, by chemical corrosion or by high heat generated, the metals tend to get corroded. So to prevent corrosion, new lubricants are used, and these lubricants make sure that the corrosion doesn't happen by action of moisture and mild production environments. And but the issue with this is if the lubricant is continuously used, once it ages, the lubricants itself tends to become corrosive. So the lubricants have to be changed now and then.
So coming to the application parts of lubricants, yeah, Ishant start. Ishant, can you come back to the other slide?
Yeah. Okay, so application based on physical state of lubricants. So as we all know, proper lubrication is a key factor affecting the performance and longevity of any mechanical equipment because they have higher temperature and the revolving speed is very high. The moving parts of industrial machine experience a large or a huge amount of stress as part of their everyday operation. So one of the main factors that allow equipment to operate under such extreme circumstances is the lubrication, which is used to reduce friction between the moving surfaces. Now we'll look at the types of lubricants.
Along with their applications. Yeah. So first one are liquid lubricants. Liquid lubricants, they are also called as oils or lubrication oils. Uh, there are several types of lubricating oils used in industrial applications. He, each have their own advantages and disadvantages. First is mineral oils. Mineral oils are composed of complex mixture of hydrocarbons and are produced by processing crude oil or petroleum oil. One of their main advantages is they're produced on a large scale basis, so they're comparatively cheaper. And next comes synthetic oils, which are man-made and using organic chemicals. They have a lot of advantages as they work at both high and low temperatures, better chemical stability, better resistance to oxidation, etc. But they're slightly expensive than the mineral oils. Fixed oils. These are biolubricants, which are usually made from animal or vegetable sources. They're rarely used, and but they're majorly used as additives in mineral oils and greases. Yeah, next, Ishant.
Yeah, so the semi-solid lubricants, as we also know them as commonly known as greases. So like grease are actually much more preferred when compared to oils because sometimes you want the lubricants to stick to a component, while other lubricants like oil they do not actually stick to they do not actually stick to the parts. So greases will not like stick to the applied surfaces, even vertical surfaces. So this is independent of a pumping system where like oil have to be pumped into the system. Grease will stick to the component, which and it'll also like make sure the asperities will also stay inside the boundary layer, which doesn't make sure that it doesn't spoil the moving parts or subject them to wear. And greases are like not subjected to leakage because they don't move so freely as compared to oil. They actually, as they have the name semi-solid, so they actually sit inside the moving parts fixed, and they mate the gears as well. Yeah. So sealant is also a type of grease which that can be packed around the component, which acts as a barrier to prevent contamination of the parts. And like you can have a grease chamber, like which is not possible for oil chamber. So this greases are commonly used in automobiles and industrial purposes, as we see them every time. And in construction equipments, the most the most used area of greases. And in cables and wires, these are made sure so that they don't actually subject them to heat, so that they don't break. Next.
Solid lubricants are also called as dry lubricants, and they're usually used where there's extreme pressure or there's a lot of dust and dirt. So all these corrosive contaminants prevent usage of mineral oils or greases. So the most common solid lubricants are graphite and molybdenum disulfide. So how these greases are used, the solid lubricants are used is either they mixed with the greases and oils when applied, and then the greases and oils are drained out, whereas a solid particle will remain there, and that will act like a lubricant for the system. Or they are sprayed with, they're either mixed with some industrial alcohol, which is very volatile. So once it's sprayed onto whatever component, the alcohol, what do you say? The alcohol evaporates, leaving behind the solid dry lubricant there. So applications used for reciprocation motion, ceramics, and high temperature areas. Ishan, next slide. Now moving on to the field of applications, ma'am.
Yeah. So in turbine lubricants must control the rust and corrosion that can destroy the precise surface, which can also resist foaming and air contaminants, which could impair lubrication and lead to equipment breakdown. Uh, they should also be easily filterable without additive depletion, and they should be versatile. Turbine lubricants should be versatile and able to serve as both lubricating oil and hydraulic fluid for various turbine system.
Now for any plane, when planes usually fly at high altitudes, ma'am, so at high altitudes the temperature is really low, so most fluids there freeze. So to prevent that, you need to choose particular lubricants where they can even with low temperatures they don't have a freezing point, so the freezing point should be really high. So that way lubricants are used to make sure the smooth functioning of the actuators for control surfaces such as rudder, elevator, and ailerons. Next.
Coming to bearings, all the bearings, such as roller bearings, plain slider bearing, or general bearing, they usually take up heavy loads, and as a result, they undergo metal to metal contact, and which results in wear. Due to wear, clearance of the bearings increases, so which will in turn reduce the load carrying capacity. So in order to eliminate this, we use lubricant. So they form a film in between the two metal contact surfaces and reduces wear and vibrations. Next.
Cams and followers. So cams are used to transmit rotary motion and reciprocating motion. These components are subjected to jerks in sliding distance, which leads to form some pits on the cam surface. So to reduce this, we use lubrication. So lubrication reduces the abrasive and adhesive wear between the cam and follower. It also reduces the temperature and prevents scuffing between cam and follower. Also, it it removes contaminants and reduces noise.
Transmission parts, our gearbox system, commonly known as, that's are found in automobiles. So in automobiles, we use lubricants known as engine oil, which ensures the smooth working of parts in the gearbox. This reduces the friction and reduces the internal heat generation of the transmission parts, as an automobile is subjected to constant varying speed at varying time. So a constant flow of engine oil should be present, and they're subjected to high temperatures, so the viscosity of the oil shouldn't decrease, as it shouldn't make them like too thin, or and at cold temperatures, the engine oil shouldn't become too cold, too hard.
These are only few, yeah. These are only few fields, ma'am. So there are other fields also, which we couldn't mention because there are like huge number of fields. That's all. Thank you, ma'am.
Okay, well presented by the team one. So I just want to ask you, what knowledge did you gain by just preparing the PPT and presenting here? Can you
Ma'am,
just
yes, ma'am. Ma'am, we know now that
Hmm.
there are different types of lubricants.
Hmm.
Okay, and they're meant for different purposes, and the way they're applied for different components is also different for specific for every component.
Hmm.
And we know the kind of properties that each type of lubricant have, and we know in general what type of properties are required for a lubricant.
Yes. So you have gained some few basic things which are essential what you have to check on before going for selection of any grade of lubricant. So again, depending
Yes, ma'am.
upon the application, the grade of lubricant, you haven't told anything related to the grade of lubricants, right? Okay.
Ma'am, our
Ma'am,
topic
it
was
was
field
actually
of
in the other topic,
application
ma'am,
Okay, it was only the importance of lubricants, right?
and field of
and
application.
applications, ma'am.
Okay.
And because you had mentioned that in the other question, so we
Okay,
didn't want to
okay,
cover it.
okay. No, no, no problem, no problem. But even that's okay. So the next team will forecast the other details. So now,
Yes, ma'am.
mainly, you were speaking about the debris and asperities. Can you tell me what you mean exactly by asperities? When does
Ma'am,
the
there are,
asperities come into picture?
ma'am, due to surface roughness, ma'am, there are bit of bumps and valleys kind of stuff on the surface, which are very minute.
Hmm.
So when these aspirates, they have very less area, so they'll induce a lot of stress because stress is force per area. So area is very less, so the stress induced is very high. So this will cause a lot of friction and it'll generate heat, ma'am.
Okay, so like whether the asperities will be more when you have like smooth surfaces across the contact, yeah, one smooth surface and one harder, yeah, all both are harder surface because of the material by which it is made in.
Ma'am, there'll be more aspirates when the surface is hard, ma'am. Because when they're smooth, it'll be flat and even, so there'll be less aspirates.
No, main thing which the problem arise when you have one softer material and other one is the hard material. Okay, so wherein the aspirate
Yes, ma'am.
is coming from the hard material will flow in into the soft material, wherein the problems arise more. Okay, so this is the thing. Fine, you have understood the concept related to the title given. Appreciate the work from your end in short period of time. I will
Thank
be
you, ma'am.
sharing the details of your marks later. So once you do the presentation, kindly put your PPT to the Google Classroom without fail.
Yes, ma'am.
Okay,
Thank you,
okay.
ma'am.
We'll do it.
Yes, yes,
Thank you,
yes,
ma'am.
yes. Yeah. The
Ma'am,
next
also,
Thank you.
ma'am,
thing,
when you're playing our PPT, ma'am, you can use slideshow and go through it, ma'am.
yeah. The next team, please.
Yes, ma'am. Yes, ma'am. Sumat, can you present your screen, ma'am?
Yes, ma'am. Just a second. Is it audible?
Yes, yes.
Yes, Sumant, you're audible,
Yes,
sir.
Sumant, we can hear you.
All right. Good morning to one and all.
Sumant,
Good
I
afternoon.
think ma'am is on the call.
Oh, okay. We shall wait then.
What's your team number before starting, Kanishka?
Uh,
Yeah,
Number we
Sumant,
don't know.
anyone?
It's
Okay, the
the
title is Classification and
topic.
Mechanism of Wear. Okay.
Yes, ma'am. Good afternoon to one and all. So our topic for today is classification and wear and mechanism of wear. So the different classifications of wear mechanisms are abrasive wear, adhesive wear, cavitation, corrosive wear, erosive wear, fatigue, and fret wear. These are the
Just go
most
back to the
common.
previous slide just a second. Sorry for
Okay,
disturbing you. I just
that's
need
okay.
to take down the USN number 22, 37, 44, and 51. Yeah, go ahead.
So these are the most common types of wear mechanisms that we see in everyday mechanical components. So coming to adhesive wear. Adhesive wear occurs when two solids, that is one which is of a harder material and one of a solar material, are in sliding contact, and the atomic bonding forces occurring between the materials on the interface are stronger than the strength of the surrounding area in either of the materials. So basically, there's a harder material and there's a softer material trying um, which are in contact with each other, sliding contact in this case. So the interface between them, that is when they two meet, there is an interface between them which is stronger than the strength of the surrounding area. And adhesive wear is one of the most frequently encountered types of wear. In adhesive wear, basically what happens is the shear starts in the weakest material, that is the where basically happens in the softer material. And
Excuse me, Sumant. Sumant, could you take it a little slow, please?
yeah, yeah, sorry. In adhesive wear, shear starts in the weakest material, and the fragment of a surface, that is the wear particle, is detached from one body and transferred to another, as you can see in this animation here. So this is the green substance is the hard material, and the blue is the softer material. So what happens here is when these two are in sliding contact, the atoms from the softer material uh, is detached from the softer material and transferred onto the harder substance. So that's what's explained here, and this is how the mechanism basically is. So if I have to explain the mechanism here, so what happens? So when two materials are in contact, there is due to the pressure and stress, that is the high pressure and stress between the two material, there is a micro weld that is formed because of the high temperatures in the contacting asperities. Here, so these two are basically glued together, and when they are when they slide off against each other, the harder the softer material loses whatever wherever the contact was, and this material is transferred onto the hard material, is what the mechanism is basically saying. And adhesive wear coefficients of materials are between 10 power minus 7 and 10 power minus 2, depending on the operational conditions and material properties. This is about adhesive wear. And moving on to abrasive wear. Prajwal, what? Are you there?
Yeah. Good afternoon, ma'am. I'll be explaining abrasive wear. Abrasive wear is very similar to adhesive wear, and this occurs when hard particles slide or roll under pressure across a soft surface. So there is additional pressure here, and this usually occurs between two similar materials. And the difference in the two materials is the hardness, and this occurs due to the formation of oxides and other chemical reactions. The very well known reasons for abrasive wear mechanisms are mentioned below, and this includes micro cutting, micro plowing, micro fatigue, etc. And in abrasive wear, there are two modes of wears. Uh, Suman, next slide. The first one is two-body abrasion, and this occurs between two materials in contact. And as mentioned earlier, one of it is harder than the other. The normal load applied forces the harder particles to penetrate into the softer surface, which in turn causes plastic deformations. And for the harder surface to slide over the softer surface, the material is removed from the softer surface by microplowing and microcutting, which is one of the most common mechanisms, as mentioned earlier. And the other mode of abrasive wear is is in the next slide. Hello.
Yeah, we can hear you.
And the next mode is three body abrasion. And in this material is removed from the softer surface by hard particles, which are free to roll as well as slide over the surface. In two-body abrasion, it happens only because of the sliding motion, but here it happens due to rolling as well as sliding motion. And due to rolling action, the abrasive wear is lower compared to two-body abrasion due to lesser surface contact between the two surfaces. But the difference is very small, and therefore we can't tell which is lesser. Um, and that is three-body abrasion.
I check. Am I audible?
Yeah, we can
Can you
hear
guys
you.
hear me?
You are
Yeah.
audible.
Okay. So I'll be dealing with corrosive wear. In corrosive wear, what happens is the any component reacts with the corrosive agent around it. Right. When this happens, a protective layer is formed over the surface. During sliding friction, this protective layer also gets weared down over a period of time. So what happens is if um, the rate of removal of this layer and the rate of the formation of this layer is same, then we can deal with this type of corrosion wear as mild corrosion wear. Whereas if the removal is faster than the growth of this layer, then it comes under severe. And that's it for corrosive wear. I would like to give it to Siddharth Shankar for the next slide.
Yeah, next slide, please. Okay. Fatigue wear is a type of wear where a number of cycles is needed to generate debris. The cyclic loading, such as rolling, bearing, gears, frictional drives, cams, and followers, are the types of substances that undergo fatigue wear. The fatigue wear process in metals may induce the generation of surface and subsurface cracks. And the two main mechanisms of fatigue wears are distinguished as high and low cycle fatigue. And the mode of crack propagation are classified as crack initiation, growth, and post-critical stages. As we can see in the picture here, at the post-critical stage, we have to stop the usage of the material as it can lead to the catastrophe. And most lifetime of the component is lies in the first stage, where micrometers and lower. Okay. Next slide, please.
Cutting wear. So usually what happens is even parts which are not meant to move, they undergo certain vibration. These vibrations have small amplitude and a high frequency. So when this happens, fretting occurs between components that are not intended to move, right? So due to this, there's a surface to surface type of wear, and this is mainly affected by the amplitude or the force, which is the normal force acting on the body, or the number of cycles, humidity, lubrication, etc., it's very difficult to avoid this kind of wear. And so it solely depends on where this wear occurs, on joints such as bolts or pin derivative surfaces, etc.
Thank you.
Okay, so well presented. Your title was like classification and mechanism of wear. So, what did you understand by going through this topic and doing your groundwork for your presentation?
We understood the different types of wear and how wear occurs in different materials and how bad of an effect it can have on everyday components that we use. Like even the most robust components that we use uh, can go through a bad cycle because of wear.
And usually, when people think of wear, they only think of sliding and rolling friction, ma'am. Whereas there are these different types of wear. That's what we found out when we did this.
Okay, so like now you're aware of all the classifications of wear which could come in when you have some relative motion across the contact area. So again, it depends upon the material. Can you just figure out like which are the major causes of wear and which is highly impacted across the surface as a drawback and which could be overcome with the help of lubricants? So can you tell me which are more worst in situation? So which are the major impact and which are the minor one associated with the types of wear what you discussed currently?
Ma'am, the major impact that happens because of wear is one is adhesion wear and the other one is abrasive. These two are play a very major role in wear mechanisms. And the least impactful is fretting, but it like over the long run, fretting can actually be one of the major causes of wear. But again, adhesion and abrasive cause wear quickly, sooner than fretting. And
Yes,
there's
ma'am.
other wear such as fatigue and corrosive, which are caused by like how we use. Like if we use a chemical, then corrosive wear is occurs, and fatigue it happens in every. It's not that big of a deal.
Okay, so have you thought about like what is the time period which usually is being needed when a fracture need to occur due to major impact of wear? Have you just gone through it?
Uh, don't know exactly the time period, ma'am, but like
Roughly, I'm asking you. The wear gets initiated if you don't come into picture or if you don't realize it just get increased and as the
yes, ma'am.
time approaches and finally it gets fractured or it becomes a scrap due to the maximum wear which is coming in.
Yes, ma'am. But most of the wear it is caused because of an initiation of a crack, ma'am. If there's no crack,
Mm.
there's not much wear. But when the crack happens, that's when wear starts occurring.
Yes, yes.
So it depends on when the crack happens. So if you're putting a component under a lot of pressure and repeated cycles of pressure, then that's how fast the crack occurs. So it depends on when the crack is initiated.
Yeah, it mainly depends upon the initiation of the crack. So after that, like usually if you go through any particular case studies wherein they have analyzed the wear, I have told you the analysis aspect of the wear and its mechanism also. There are different type of analysis what they go in depending upon the application. So if you go through that type of real time case studies, right, related to the mechanism of wear, so there practically you'll come to know where after the initiation, which is the rough time within which an device could come into fracture. Okay, so that you can just check through some of the case studies. Fine.
Yes, ma'am.
Yes, and you guys also kindly upload your presentation to the GCR immediately.
Ma'am, only one of us have to do it, no, ma'am?
What?
Only one person in our group has to do it, no, ma'am? Or all of us have to upload?
No, 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 no. Only one. In that, all your name and USN is there, no?
Yes, ma'am.
Per team, one PPT only. Not every individual will upload it.
Okay, ma'am.
Okay. You just mention your everything in your slide will be there, right? The title, the student's name,
Yes,
everything. So
ma'am. Yes, ma'am.
accordingly,
Yes,
I
ma'am.
will share the marks for all the students.
Yes, ma'am. Thank you, ma'am.
Okay, okay. The next team, please. Which is the next team who is going to present?
Yes, ma'am, will do, ma'am. Chetan, could you please share the
Jason. Okay, okay. What's your title? Type.
ma'am?
Yeah,
Shall
I'm
we start,
noting
ma'am?
down. Yeah, you please start. I'm just noting down your USN numbers.
Okay, ma'am. Okay. Good afternoon, ma'am. Today our topic is types and properties of lubricants, and my teammates are Anil Kumar, Chetan, and myself, Dheeraj. Chetan, change the slide. Types of lubricants. First one is animal oils. Animal oils and fats are lipid materials derived from animals only. Physically, the oils are liquid at room temperature and the fats are solids. Chemically, both oils and the fats are composed of triglycerides. And the second one is vegetable oils. Vegetable oils are oils extracted from seeds, which means the part from fruits only. Next one is mineral oils. Minerals oils are the various colorless, odorless, light mixture of higher alkalines from minerals sources, which are hydrocarbons obtained from minerals. Next, synthetic oils, which comes from various chemicals. Greeks, semi-fluid lubricants, dry or solid lubricants means molybdenum disulfide or graphites. Chetan, next slide. And also solid lubricants and are also called dry lubricants. These are the materials despite being in a solid phase that are able to reduce friction between two surfaces sliding against each other without need for a liquid oil medium. Uh, the two main lubricants are graphite and molybdenum disulfide. And semi solid lubricants means which is the most important gasoline, waxes, and other components of oil and fats. Liquid lubricants means which are extensively in applications that highly terms of speed and load size. Mm, Liquid lubricants are the most dominant type of lubricants in markets. Next, synthetic lubricants means which are chemically compounds that are artificially made. Synthetic lubricants can manufactured using chemical modified petroleum components rather than a whole crude oil, but also can synthesized from other raw materials also. Next, I'm handing to Anil Kumar.
Yeah. I'm going to explain about some properties of lubricant. First one is viscosity. Viscosity, as we know that every liquid have a viscosity, which is nothing but it is a resistance offered by the liquid in subsequent layers of the liquid layer. Um, like high viscous liquids cannot flow, which are examples like olive oil or grease, and the less viscous liquids like water can flow easily. And second property is like on oiliness. Oiliness is a ability of a lubricant by virtue of weight. Uh, they offer low coefficient of friction. Low coefficient of friction with the same liquids. And it is a measure of by which the lubricant stick to the surfaces of the machine parts. Like third one is stability. In stability, for lubricants we mostly need stability, like thermal stability, and chemical stability. Stability is nothing but retention of the properties of the lubricant. Chetan, next slide. Chetan, hello. Yeah. Corrosion stability. Corrosion stability. Most of the lubricants which have a disadvantage like corrosion of material. Uh, a lubricant should be uh, a lubricant should not be more corrosive. Mm, it should be a it should be stable from corrosive point of view. And next property will explain by Chetan.
Hello.
Yeah, we can hear.
Yeah, kindly present.
Yeah, uh, thermal stability. Like all we know, like all the oils have the tendency to decompose at higher temperature. Like the ability to resist decomposition due to high temperatures is known as like the thermal stability. The good lubricant should not decompose during operation at high temperature, and it must be stable towards the heat. And the next property is like the volatility. The volatility is the evaporation behavior of the lubricant at high temperature. When the lubricating oil is used in very heavy machinery working at high temperature, a portion of oil may vaporize, leaving behind the residual oil. These residual oil, like they have different lubricating properties like increased viscosity and all. Therefore, the good lubricant should have very less volatility. Uh, and then the next property is emulsification. Like the property of oil to get mixed with the water forming a mixture is known as emulsion. Emulsions have very high tendency to collect dirt and the other foreign matter. Uh, these cause the abrasion and wearing out of the lubricated parts. Therefore, like a good lubricant should have very low emission number. Yeah, thank you.
Hello.
Hello.
Yeah, what was your topic? It was like types and properties of lubricants, right?
Yes, ma'am.
Yeah. What knowledge did you gain by doing some groundwork for your presentation work?
We got to know like there are
One at a time.
we got to know about the different properties like based on what we need to what all properties we need to see by selecting the lubricants and
Did you check any real-time case study on selection of lubricants?
no, ma'am.
No, that was supposed to be done actually from your end. Then you will come to know, like now you know that what are the properties of different lubricants, what are the types of lubricants, how you categorize into like for which type of bearing material you will go with which type of lubricant, which grade of lubricant you want. So which are the required properties. So that correlation you'll come to know only if you refer some case studies. Okay, so that you have to do. So that was the need why I figured out the title and that you people have not gone through. Okay, at least can you tell me like which type of lubricant you need to select for the set of properties? Go back to your slides, share your PPT. Be quick. Yeah, the properties, right? You're mentioning various properties of lubricant. Sometimes you may need a less viscous lubricant. Sometimes you may need a high viscous lubricant. It also depends upon which type of bearing you're using, which is the type of load which is coming into picture across the contact area. So based on whether heavy loading, you're lightly loaded. So you need to select the type of lubricant. So every lubricant needs a set of properties. So which are the minimum properties a lubricant should have? Can you just speak on it? Is it all are very much essential, or
Yes,
there
ma'am.
are key properties what a lubricant in general has to possess?
There are some key properties, ma'am, like viscosity, stability,
Mm,
and oiliness are some key properties, ma'am. Like in bearings of automobiles,
mm,
there will be high load, ma'am. So
mm.
we need high viscosity, and oiliness of the lubricant, ma'am.
Okay. Still, if you would have had one case study, that would have been better. So try to do a little bit of groundwork further so that it provides you a knowledge totally which lubricant you can select for which type of requirement. That I have told you in case of our class also with respect to some examples. I thought you will give the case studies related to all the type of lubricants that will fetch more information for a real time requirement, because usually there'll be huge lot of specifications for every grade of the lubricant. So based on your requirement you will see that whether the specification is mapping and you'll go with that grade of viscosity lubricant basically. And again it depends upon what are the set of properties you are in need for specific type of requirement. So based on those set of properties you need to select the grade on available viscousness of the lubricant. So selecting becomes a difficult task if you don't have a scheduled data with you. So if you do the minimum groundwork before purchasing a lubricant, right? So these are the availability which is mapping as per your requirement. So then you can directly go and purchase the required lubricant. If you go wrong in selecting the lubricant, even though the design of the bearing is good, the material selection for the bearing is good, right? Even though the load applied is completely bearable, if the lubricant what you have selected is wrong, so then the reliability of that particular bearing will come down. The life of that will come down. So you should be very careful in selecting the lubricant. So these properties and types really plays a very vital role. So you should be very keen enough and you have to go with some real time applications. Okay.
Okay.
Yeah, you kindly share your PPT to the Google Classroom. Any one of you, either of the three, anyone can share me the PPT in the Google Classroom. Okay.
Yes,
Sure.
ma'am.
Yeah, next team, please be quick.
Yes, ma'am.
Share your PPT.
Hello.
Yeah, proceed.
Um, Good afternoon, ma'am. Our topic is importance of tribology in design and product development. Balaji, next slide.
Just a second, I'm noting down. Design and product development, is it? Okay. USA number 10. Just go down. Go back. 10, 19, 33, 52, and 61. Yeah, please start.
Now, coming to the question, what is tribology first? Tribology is the science that deals with friction, lubrication, and wear of surfaces which have relative motion with each other. The word tribology comes from the Greek word tribos, which means rubbing. Next slide. Tribology is an interdisciplinary subject which has elements of fluid mechanics, solid mechanics, material science, chemistry, and thermodynamics. The knowledge of tribology has led to a development of better materials and lubricants, which help in reducing friction and wear in mechanical and electromechanical systems, which right now are the major bane in our modern society as they lead to inefficiencies and loss of energy. Next slide, Balaji. Tribology in design and product development. The testing which we do under tribology helps us to understand how the materials wear on rubbing with each other and how friction acts when two materials have relative motion with each other. This also helps us to understand what type of lubricants that we need to use in this particular situation to reduce the wear and friction so that we can get more efficiency and reduce the wastage of energy. Next slide. So tribology is mostly concerned with optimizing the contact surfaces to prevent wear and the use of material between the the material that is used between the contacting surfaces has a major impact on how each of the surface reacts when applied when force is applied and depend on the stresses which is applied. The use of friction and wear optimized materials can greatly improve industries as they can reduce the downtime and maintenance that is required to be done on the machines. Balaji, next slide. Now, Balaji will be giving the brief introduction on the various applications of tribology.
Thank you, Nikhil. So yeah, tribology plays a very big role in our day-to-day lives. So as you can see, it has applications in various fields such as automobiles, drilling and hardware equipment manufacturing, biomedicals, aerospace, aeronautics, even racecrafts and many such other fields. The main application of tribology in design is comes down to bearings, gears, cams, brakes, and seals. Scrap, sorry. Siddharth will talk next.
Okay, so talking about bearings, in mechanical systems, bearings are used for supporting the various rotating elements like shafts, etc. A special feature of journal bearings is that it makes metal to metal contact only in two conditions, one at the start of rotation and other at the end of the rotation. Only in these two conditions wear of journal bearings occurs and is maximum and significant. Often such failures occur in absence of sufficient lubricant hydrodynamic film thickness due to relatively low speed. Bala, next slide. Learning tribology cultivates an understanding that at low speeds, the main purpose of oil is the lubrication, and high viscosity oil will be preferred to low viscosity oil. While at high speeds, the major purpose of oil is to act as a coolant, and low viscosity lubricants are preferred to carry away frictional heat of operation. Here, lubrication is a secondary consideration.
Gears are very important for transmitting the power from one shaft to another. So, tribology helps us to investigate the various tribological aspects of gear and the reasons for failure and preventing these failures. As we know that maximum deterioration of gears takes place on surface of gears as teeth are responsible for power transmission. Balaji, next slide. Gear failure takes place when the teeth loses its shape. Major causes of gear failure are friction and scuffing, and this can be avoided by using lubricants or harder gear profiles or different coatings on the gear tooth.
Hello, ma'am. So cams are components that are used to transmit rotary motion into reciprocating motion. These components are subjected to many cycles of usage and tend to fail with increasing usage. So one such failure is the pits formed on the cam surface. These pits can increase noise pollution and reduce the mechanical efficiency to a greater extent. So tribology as a subject helps us to realize what are these limitations of such components and helps us to increase their efficiency in any way possible. And also mechanical seals. These are devices that join systems or mechanisms together and prevent any kind of leakage or uh, protect the system from any contamination. So the effectiveness of a seal is dependent on the adhesion in the case of a sealant and compression in the case of a gasket. So the as you can see, the possible failures are when there's a adhesion wear in the case of sealant and failure of the gasket. And so tribology helps us to prevent, understand these causes of wear and prevent them, and hence increase its efficiency.
Thank you, Vidyan. So, in short, tribology is very important in our lives. So, there are many benefits. Some of them are saving money. So, in any industry, money is of utmost importance. So, if someone does frictional analysis or anything in a prototype before the product is even developed, we can save a lot of money by solving any problems that occur. It'll also help save time because frictional analysis it provides fast, accurate, and reliable measurements, and it helps the manufacturers to develop their product quicker. The product quality can also be improved because we can see where the wear is increasing or improve the product as we are in the prototype stage itself. Uh, as we do frictional analysis, we can also improve. We get to know about our product. So as we keep developing, we'll have a lot of product knowledge, which will help us streamline the product and, in the end of the day, make something better for the society. Thank you.
Hello.
Hello.
Okay. Oh, it was a good effort which was being done from your end. I think the title was Importance of Tribology in Design and Product Development, right?
Correct, ma'am.
So what did you gain knowledge? What is the basic importance of tribology if you want to design any new product? Suppose you want to design a new pen as per some innovative concepts. So what is the impact of tribology on designing a new pen? Can you just tell me an example for this? Yeah, Mr. Balaji was very happy in presenting. Can you please answer me now very well so that even
Hello,
I'll be
ma'am.
happy? Yeah. Yeah, Vidyan.
Yeah,
Ma'am,
as
your
Balaji
voice
had
is
explained in the
breaking.
last slide,
Uh,
there were four main benefits of this in product design and product development.
mm-hmm.
So, in case you're developing a product,
Okay.
so when you expose these products under various testing conditions,
Mm-hmm.
you realize at the maximum at which you can push these products, these components can be used, at what
Mm-hmm.
level they fail, and many such information you gain, and these data can be used to make the product better, so that in actual application they don't fail as early, or you know yeah.
Okay. What else you understood from your presentation work?
We just making this presentation, we understood that how tribology as a subject is huge, and how its roots are uh, embedded in almost every field. And so we can also infer that making certain changes in the basic development of a product or design can save it from failure, and also save money and time for the industries, and also give a
Okay.
better product to be relied upon by the customers.
Okay. What about the team effort? A single individual prepared the PPT, or it was like a group
No,
effort?
ma'am.
How was
It
it?
was a team effort. It was a very big team effort, ma'am. We all of us got together.
Okay.
We researched about tribology. We just thought it was an elective at the end of the day, but we found out the importance of tribology in our lives, and the role it plays in our day-to-day lives. It is such an
Okay.
important topic. So yeah, we learned a lot about tribology, ma'am.
Okay, okay, okay. So some were presenting only for the sake of marks. Even the title was that in one of the teams. So I just asked how was the effort given by the
No, ma'am.
others.
This was a very big team effort, ma'am.
Yes, so you will realize the importance when you start working on it. Okay, so it is a small type of trial, so wherein you can know the importance of tribology as a subject in various stream of
Yes,
engineering as well.
correct.
So fine, it's good. So can we take one
Thank
more,
you.
or we will end here and take the remaining sessions tomorrow?
Ma'am, can we please end
Ma'am,
it?
can we
We have lab, ma'am.
Okay, no problem. Tomorrow, I think I have first star class, is it?
Take now, ma'am. We will do.
So we'll take
can we
tomorrow.
have a round of applause for all the teams that have
What?
Now.
Okay, okay. So it was a good effort from each and every individual with respect to the team as well. So all have given their best of presentation and gained some knowledge also related to the topic which was assigned to you guys. So I think the remaining batches will carry forward in tomorrow's class. Since you have lab, Roshan, you want to present today?
We don't want
Hello?
to carry forward, ma'am. We don't want to carry forward.
Okay, if you want to present, I'm here. You can do it. And before that, see that everyone type your name and USN. If I call now the attendance, it takes time for others who have the laboratories. See that you write your name and USN in the chat room before you leave. And those who have completed now the presentation, kindly upload the PPT in the GCR immediately. Yeah, Roshan, you can share your screen.
Okay, ma'am. Niharika, start.
Yeah,
Ma'am, may I?
One second, ma'am. Can I just speak to you, ma'am?
Yeah, please.
Can we go after Roshan's batch, ma'am?
What?
Can we present after Roshan's batch, ma'am?
Even you want to present?
Yes, ma'am. After this, we'll just finish it off, ma'am.
Ma'am, even
Okay.
we'll present today, ma'am.
And we'll present today, ma'am.
You don't want to have your lunch?
No, ma'am, we don't have lab after this, so we'll do it now.
We'll do it off now.
Okay, fine. After Roshan group, you people can carry forward. So let us just take a 5 minutes break and we'll start. Okay. Pavan and Sagar.
That's fine.
Yeah.
So,
Yes,
ma'am,
yes. Yeah, please. What's your title? It is?
Ma'am, classification and mechanism of wear.
Okay.
So good afternoon to one and all present here. So today we will be presenting the topic on classification and mechanism of wear. So before undergoing the depth of the classification and the mechanism of wear, let us understand what is a wear.
What's the, just a second, your USN number 3143, it's not visible.
Ma'am, 31, 42, 43, 7 and 16 ME046.
16 ME046. Yeah, please proceed.
Roshan. Hello. Yeah. So, what is a wear? Wear is defined as the surface damage of one or all these solid surfaces in a contact subject to relative motion. Wear might have a different pattern corresponding to the various wear mechanisms. A surface can be subjected to more than one wear mechanism simultaneously. So, the wear can be basically classified into the two basic types, that is, the zero wear and the measurable wear. So, what is a zero wear? Zero wear is basically a polishing process in which the asperities of the contacting surfaces are gradually worn off until a very fine smooth surface develops. It may increase the performance or it can be considered as a desirable one. So let's understand the measurable wear. It can be a removal of a material from the surface that increase the vibration, noise, or the surface roughness may be treated as the measurable wear. Often we can measure the wear in the terms of the volume or the mass reduction. The undesirable removal of the materials occur in the measurable wear. So now I request my batchmates to further take you on to the classifications of the wear.
Okay, start. In case you are muted, unmute yourself. Is not audible.
Roshan, you can continue, no?
Yeah, okay, fine.
Yeah, anyone please continue.
Okay, we will go for the abrasive wear. In
Yeah,
simple words, abrasion means scraping off, means the material which are in contact will be scraped off. So it's something called as cutting where occur when hard materials slide and roll under pressure across smooth surface. Hard particle sources are mainly dirt particle, metal wear particle, and particle introduced in housing when filling of tube oil. We can observe this when we see when we take the example of a rolling bearing. So while in rolling bearing, if we take a lubrication and with the lubrication, if some particles are going in the bearing, so it may start damaging the wear. Scratching is a form of abrasive wear which is characterized by short scratch lines in direction of sliding. This type of damage is usually light and can be stopped by removing of contaminants that caused it. Basic mode of abrasion wear are mainly of two types, two body abrasion and three body abrasion that was done by other group. So we didn't take much about that. Following a few well-known reasons for abrasive wear mechanism. Micro cutting, sharp material cut softer surface, cut removed as wear debris. Micro fracture generally occur in brittle, fracture occur due to merging of number of smaller cracks. Micro fatigue, when a ductile material is about by a blunt piece, the one surface is repeatedly loaded and unloaded, the failure occur as fatigue. Now, Ranveer will carry forward.
Good afternoon, ma'am. Hello.
Yeah,
Ma'am,
please proceed.
yes, ma'am. Ma'am, I'm going to start with corrosive wear.
Yeah, yeah.
Corrosive wear is similar to that of abrasive wear. It is defined as the degradation of material in which both corrosion and wear mechanisms are involved. Corrosive wear occurs when the environment surrounding a sliding surface is corrosive and interact chemically with the sliding surface. Therefore, this wear is also known as chemical wear. Roshan, next slide. Now, cavitation wear. Localized impact of fluid against the surface during the collapse of bubbles is known as cavitation wear. Now, erosive wear, the damage produced by sharp particles impinging on an object is called as erosive wear. Particles in water and eroding the rocks over which river flows, or the erosion of both rope and stone pulley when rope continuously slides over the pulley, are some of the common examples of erosive wear.
On the
Fretting
fretting
wear.
wear part, continue.
Fretting is a small amplitude oscillatory movement that occurs between contact surfaces, which are usually nominally at rest. One of the immediate consequences of the prices in normal atmospheric condition is the production of oxide derbies. Hence, the term fretting wear or fretting corrosion is applied to the phenomena.
Fatigue wear. It is attributed to multiple reversals of contact stresses occurring due to cyclic loading, such as rolling bearing, gears, friction drives, cams, and followers. At the start of bearing operations, the rolling bearing rely on smooth, undamaged contacting surface for reliable functioning. A certain number of rolling contact cycles must elapse before surface defects are formed, and there is formation in terms of contact fatigue. Once the rolling surface of a bearing are pitted, its further use is prevented due to excessive vibration caused by pits passing through the rolling contact. Ankesh, are you ready? Is your mic working?
Yes, Roshan, I'm ready. I'm ready.
Okay. Now Ankesh
Hello.
will be doing the adhesive part.
Yeah, proceed.
Look, can you bring the slide to
Okay.
this? Yeah, fine. Yeah, hello, ma'am. Am I audible?
Yeah, yeah, please start.
Yeah, okay, ma'am. And first of all, adhesive wear is very common in metals because of the property called adhesion, which exists in the material, and it is heavily dependent on the metal affinity between the materials. And the theories we studied the wear rates start from the concept of true area of contact. It is usually assumed that the true area of contact between two real metal surface is determined by the pretty deformation of their highest asperities. And also severity of adhesive wear is determined by the area of contact, which is given by the W by H. And Roshan, can you move to the next slide? And W is the load which applied to one surface over the other, and H is the hardness of the soft material. And I'm taking an example, which is one material is indium and another is steel or brass. So the material which is of brass is a contact material. A load is applied of magnitude W over the surface of indium metal. As the load is applied, a heat is generated between the materials, and some transfer of material takes place between the steel metal and indium metal. And due to this, a bond is created between these two metals. And suppose if we applied one more force, which is given in figure C, that is tangential force, then due to this force, the material, that is indium metal, starts sliding over the metal which is below. So due to this, some deformation occurs, and this all happens due to the adhesive wear. So to remove the adhesive wear, we are applying some grease, due to which the severe wear that has occurred between the material is reduced to mild wear. So that's all options.
Fine. What knowledge did you gain from this?
And
Still something is there to present?
No, ma'am. It's over now.
Okay. So this title was presented by the other batch as well. So what knowledge
Yes,
did
ma'am.
you gain by knowing about the classification and mechanism of wear? Which type
Yes,
of
ma'am. Here
wears
we get to know.
are the worst and which could be overcome? So just speak about that.
Ma'am,
Yes, ma'am. Here we
abrasive
get to
and
know
adhesive are the most common, and the one which is useful is zero wear, because after some time the roughness is gone and the smooth surface is produced.
Hmm. Okay. Which is the most worstly affected one? Which is the
Ab-
major type of wear which can?
Abrasive and adhesive.
Okay. So any precautions you can take to reduce this type of abrasive erosion?
Yes, ma'am. We can apply oil and grease to reduce the abrasive wear and adhesive.
Anything related to the type of material you will have, if you select and if you select a proper grade of lubricant, can this part of it could be reduced somehow?
We can also select a harder material, ma'am, which has more hardness, which has property like more hardness it is. The
Exactly.
material which is more hardness.
Yes, so the material which is more having more hardness property in it, so this will help to reduce the wear to the maximum extent. So mainly, even though the design is good enough, so you should see that the material you have selected the right one with respect to the right strength and hardness, wherein the wear will come down drastically. Okay.
Yes, ma'am.
Yeah. And what about the team effort? How you people finally did all the work?
Ma'am, all together, ma'am.
All together, sure.
Yes, ma'am.
And our team also has taken one case study, ma'am, which is given by Spencer.
Okay, which case study is that? Fine, you can share
It
that
is
case
related to
study. Okay, you can share that case study along with your PPT to the GCR. Okay.
Okay, ma'am.
Yes,
yeah. Okay, ma'am.
yes. Next team who wanted to present?
Yeah, ma'am. Can we go ahead, ma'am?
Yeah, please.
Junaid?
Yeah. Yeah, I'll start now.
Yes.
Uh, Good afternoon, everyone. We selected a topic importance of tribology in design and product development, and it is presented by Abdul Khalik, Vivian Varun, and myself, Mohammed Junaid. What is tribology? Tribology is a science that deals with friction,
Abdul,
lubrication.
Varun, and who else?
Mohammed Junaid, ma'am.
Okay.
Yes, ma'am.
Yeah, done.
What is tribology? Tribology is a science that deals with friction, lubrication, and wear in all contacting pairs. And the knowledge about tribology helps us to improve service life, safety, and the reliability of interacting machine components and yield substantial economic benefits, such as cost and all other things. It is not an isolated science, but rather than a complex, multidisciplinary endeavor where advances are made by collaborative efforts of researchers from fields including mechanical engineer, manufacturing, material science engineer, chemistry and chemical engineer, physics, mathematical and biomedical engineer, computer science, and more. We will next slide.
Yes.
Now we will talk about the problem faced by an tribologist. The greatest challenge which is faced by a tribologist is that the friction and the wear values cannot be easily transferred from one system to another. Example, from a tribological test rig to a real application. The most important, I think, the most difficult part of tribologist is the comparison between measured values are only feasible when based on a very similar typological system. And the tribological behavior of material can only be estimated for specific applications based on modeling and simulation testing, provided that the specific operating conditions of the applications and the test environment are the same. Last, the tybologist main task is to study, examine, and eliminate the effects due to friction and wear. And the next scenario of typology in design will be taken care of by Abdul.
So the tribology in design, some of the applications require low friction, example bearing materials. Other require high friction, example brake systems. Study of fluid flame bearings, rolling element bearings, seals, gears, cams, brakes are some of the applications in which the tribology is required. And some basic knowledge gained by the tribology course is very useful for industry related to power, steel, cement, oil, etc. Practicing such knowledge is a problem ranging from household appliance to large sized ships, earns great economic benefits. Tribology course is often named as industrial tribology or applied tribology. Vivian, next slide. When designing experiments describe friction and wear, tribological testing can be placed into one of the six main categories, from field test in category 1 to the simplest laboratory model test, category 6. For the first category, a field trial is conducted under the normal operating conditions, which may include extended operating conditions. This results in poor repeatability but is close to the real world requirements the tribological system will face. And the second category is experiments are undertaken with a complete piece of equipment in a plant environment. These experiments may achieve results close to the normal operating conditions and can be conducted over a period of time to replicate extended operating conditions while limiting the environmental impact. And the third category, components, subsystems, or assemblies are tested in a laboratory approximating normal extended operating conditions, yielding the medium repeatability. And fourth category, laboratory testing is conducted on serial standard components using scaled down testing plant apparatus. And the fifth category is experiments are conducted on a specimen with test equipment to deliver close to normal operating conditions with excellent repeatability. And the last category, a bench test is conducted with simple laboratory test equipment. And the next part will be carried by my friend Vivian. Vivian.
Yes, ma'am. Now we're going to talk about how we're going to apply these test categories to a sub-tribo system bearing. So, tribological testing of bearing materials can be divided into four main categories: product performance descriptions, which would include categories 4 and 3 to ensure the transferability of results; production manufacturing monitoring, including categories 6 through 4, with category 3 also being a possibility. Customer related testing of bearings may include categories 3 to 5 through 5, keeping in mind that category 5 is relevant only if the test can be adapted as close as possible to the application. All categories may be used to support material designers, with lower categories in early stages of development for pre-selection and higher numbered categories coming into play as the subcomponents and the final product are available. So, in conclusion, this tribological system is composed of the collective stress operational inputs, system structure, and functional and loss outputs. The collective stress includes technical and physical load parameters, including load, sliding speed, and duration, along with the movement and temperature conditions stressing the system structure. The system structure is determined by the property profiles of the substantial elements, including the base, opposing body, and the ambience, and the intermediate medium. Tribology shows us that it is an important aspect in product development and design. Thank you.
Okay, so what was the knowledge you gained overall by doing this work, Abdul
Ma'am,
and team?
So, ma'am, initially what we found out was tribology isn't just one field, but it is an application-based field in where you can apply it in almost n number of fields, ma'am, as we have defined in the introduction. Also, we have found
Mhm.
out that tribology is what does it, if you want to become a tribologist, what are the types of problems you face? So that because engineering is basically mainly importance is to solve problems, ma'am. So we found out that the problems faced by certain tribologists are these, and based on this, how are they categorized? How to solve these kind of problems in design, man? We found out there are six categories, and in these six
Mhm.
categories, we have found out the different levels of testing, with six being the easiest and the most repeatable repeatable one, and category 1 being the most difficult, and also it shows us the real time application map. And then we have found out, using an example of a tribo system bearing, we have found out how to apply these test categories, and we have explained it to you as well, ma'am. And then in conclusion, we have told you why tribology is important, what are the different parameters important, and everything else we have to take during a design and a development phase through any product. So that is what we have found during our experimentation. Yes, ma'am.
Yes, so it is neatly presented. You have done your groundwork. You were able to identify the problems faced in actual by some tribologists. So that is an good effort what is being done. And later you have spoke about the available the other categories and options. So that's fine enough, and you have done a proper work as per the title which has been given. So appreciate the work done by you guys.
Thank you, ma'am.
Right. Yeah. Even though the title was same, you have presented in a different way. So, like, have you referred some of the just case studies or some research papers as well?
Ma'am, we tried to refer some research papers, but they were all requesting access, ma'am. So we didn't have enough
Okay.
time to do it.
Yes,
So
ma'am.
Yeah.
if you
Yeah.
give us another chance, we can try it out, ma'am.
Okay. 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 No problem. So you can kindly share your PPT to the GCR immediately.
Yes, ma'am, I'll do it, ma'am.
Okay.
Yeah.
Thank
Yeah.
you.
Yeah. 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 Done. Thank you. Anyone
Thank you,
else
ma'am.
who is interested to present?
Yes, ma'am. We'll present, ma'am.
Yeah. Yeah. I think you people are the last team, na?
Yes, ma'am. Yes, ma'am.
For today.
No,
Okay.
ma'am. We are also left.
You want to present it today only?
Yes, ma'am.
Okay.
Okay. Shall I start, ma'am?
I'm just noting down your, you can start. I'm just noting down your title and your USA number. You please
Good
start.
afternoon, ma'am. We are a group of 3 members. Myself, Sagar, and other 2 members are Subramanya and Pavan. We'll be presenting the topic importance of surface coating for wear and corrosion resistance. Next slide.
Yeah, proceed. Kindly go for next slide. Your slide is hanged out.
Subramanya, next slide.
Subramanya, please move to the next slide.
Just give him a ring. I think he might not be there in front of a PC.
Or else, Sagar, you only present it.
Or else the other team kindly present until you guys, if you have any problem as such. Will it take much time for you people to start up with?
I will do it, ma'am. I'll do it.
Yeah.
Ma'am, or else let the other team do it,
Yeah,
ma'am.
that's what I told. Let the other team kindly do it. Be
Yes.
quick. It's, yeah.
Hello, ma'am. Can you start, ma'am?
Yeah, please start. Share your screen.
Okay, ma'am. Good morning, everyone. So today our tribology presentation is based on the topic origin of friction and reducing friction in metals and non-metals. So these are my group members. In the next slide, I'll show you how the friction originated and how it was first discovered. So at first, there was a scientist, Leonardo da Vinci. In 1493, he documented in his notebooks about sliding friction and its laws. But unfortunately, these laws could not be published, so it remained hidden till then. So the next scientist, Guillermo Amontos, in 1699, these laws were again rediscovered by him, and so these laws became known as his laws, Amonton's laws of dry friction. Next, he presented that the nature of friction in terms of surface irregularities and the force required to raise the weight pressing the surface together. After that, there was another scientist called John Theophilus Desargues. In 1734, he recognized that there was also a role of adhesion in friction. He studied the microscopic forces that cause the friction surface that cause the surfaces to stick together due to adhesion, and he proposed that friction was the force necessary to tear the adhering surfaces apart. Uh, and after that, this study was further developed by another scientist called Charles Augustin de Coulomb. In 1785, he investigated the influence of four main factors in friction. The first one was the nature of materials in contact and their surface coating. Next was the extent of the surface area, and after that, he investigated about the normal pressure or load, and then he investigated about the length of time that the surface remained in contact. So this was the first initial study that was originated the study of friction. And further, there were many other scientists, those that carry forwarded this study. So there was another scientist called John Leslie in during his period of 1766 and 1832. He noted that there was weakness in the views of Amontos and Coulomb. So he knew that if friction arises from the weight being drawn up the inclined plane of successive asperities, then why doesn't it balance through the descending of the opposite slope? So in his view, friction should have been time independent process of flattening, pressing down asperities, which created new obstacles in what were the cavities before. So there was another two scientists, Frank Philip Bowden and David Tabor. In 1950, they studied friction in microscopic level, and they studied about the actual area of contact between the surfaces. And he knew that there was a surface fraction, a small fraction of the apparent area. This actual area of contact was caused by the asperities, which increases with pressure. And the development of this atomic force microscope enabled scientists to study friction in more atomic scale. So this atomic force microscope was used to study friction in a more atomic level, and it showed that dry friction is a product of intersurface shear stress and the contact area. These two discoveries explain the first law, which was given by Amontons, and the microscopic proportionality between the normal force and the static frictional force between the dry surfaces. So there were another scientists called as L.A. Sosnicky and Sharkabov and Komisarov, who showed that this frictional force was proportional to both the contact and the volumetric load, if the volumetric load caused the cyclic stresses. So the next slide is on reducing friction in metals and non-metals, which will be done by my friend Nirav.
Good afternoon, ma'am. And in reducing the friction in metals and non-metals, we can reduce it by making the surface smooth by polishing. The friction is due to the roughness of surface. So if we make the surface smooth by polishing, then the friction can be reduced. For example, like in swimmer wear suits which reduce friction resistance. Since these suits are particularly made with a particular type of material where the friction is reduced as much as possible. And another, we can use lubricants. In lubricants, so basically we can make use of oil or grease which is applied between the two moving parts of a machine. So basically a thin layer of oil and grease will be formed between the two rubbing surfaces, hence separating both the material surface. Hence the friction is reduced and the movement becomes smooth. The another we can make by reduce is by making the body or a body of a particular material a streamline. Since a streamline shape allows air or water to flow around it easily, offering the least resistance. For example, comparing a boxy old car which you used to use in old generation to new cars, new sports car that we use, which are more streamlined and hence offer less resistance and provides more speed. The next slide will be covered by Rishabh.
Yes, ma'am. Friction can to reduce the forces on acting on the surfaces. The stronger the force acting on surface, the higher the friction. So reducing the force acting on surface will also reduce the friction. For example, if we apply handbrake when you try to drive the car will have a lot of difficulty moving because of the force which it applies on the wheels. And when we release the handbrake, the wheels will move more freely because there is no force acting on them. And when it can also be reduced by reducing the contact between the surfaces. Uh, the example is if we ever try to roll a cube, spheres are best shape for reducing friction because very little of spherical object is in contact with the other surface. Several type of wheels such as skateboard wheels contain small spheres called ball bearings to help them reduce the friction between the moving parts. Um, we can also witness the effect of ball bearings by comparing the friction between sliding a book on the table and then doing the same, but using marbles between the book and the surface of the table. Uh, then we notice how the marbles start to act as ball bearings, which help to reduce the friction between the surface. Thank you.
Hello.
Yes, ma'am.
Yeah. So what knowledge did I didn't note down your PPT title and the student's name because it
Oh,
was the other group right before.
yes, ma'am. Ma'am, our title is
Yeah, please tell.
Origin of Friction and Reducing Friction in Metals and Non-Metals.
Origin.
Of friction
Okay.
and reducing friction in metals and non-metals.
And reducing friction in metals and non-metals. Okay.
Yes,
You
ma'am.
just tell me your USN numbers.
Ma'am, USN 20,
Okay.
23.
23.
Yes, ma'am.
Okay.
24,
Uh-huh.
35,
Okay.
and 41.
Okay. Okay. Fine. So what did you learn from this topic basically?
Ma'am,
Ma'am, first of all, the topic itself, origin of friction. So first of all, Leonardo da Vinci, we got to know that Leonardo da Vinci first found out about the laws of dry friction,
Mm-hmm.
and from that, various scientists modified his work, like Giuliano Mentos and Charles Augustin de Coulomb. All of them modified theories, what was proposed among us, sorry, what was proposed by them or their successors. So finally in 1950 we got to know the atomic force microscope. Through the atomic microscope we found that friction is a product of inter-surface shear stress and the contact area. So the two discoveries, the first one, the Manton's first law, and the help development found out by the atomic force microscope builds our entire base
of this origin of friction. And the second part, the reducing in metals and non-metals. So simply, how do we reduce friction? So friction, simply we can say, to make the surface smooth. So how do we make surface smooth? We can use lubrication, we can use oil bearings and other friction reducing objects, or we can make the object streamlined, or we can reduce the force acting on the surface, or we can reduce the contact surface between the surface. This is the crux of what we have presented today.
Okay. So how was what about the team effort, teamwork?
Everyone help.
Fine then. Let me go on with the last presentation. You kindly share your PPT to the Google Classroom. Okay, immediately, right now.
Okay.
Thank you.
Thank
Okay,
you.
ma'am.
Yeah,
Thank
yeah,
you.
yeah. Thank you. Yeah, Sagar and
Thank
team, kindly. Thank
Yes, ma'am.
you. The last team, kindly do present.
Um, Good afternoon, ma'am. We are group of three members. Myself, Sagar, and other two members are Subramanya and Pavan. We'll be presenting the topic importance of surface coating for wear and corrosion resistance. Next slide. Um, I'll start with surface coating. Surface coating is nothing but any mixture of film forming materials plus pigments, solvents, and other additives, which, when applied to a surface and cured or dried, yields a thin film that is functional and often decorative. The main reason for coming up with surface coating is that the fact that combined effects of wear and corrosion. Importance of Okay, next slide. Importance of coatings are it is required to achieve desired characteristics, and it helps in surface modification. Moreover, coating provides higher melting temperature, maintain high hardness and strength at elevated temperatures, better erosion and wear resistance, higher resistance to corrosion and oxidation. Um, Rest will be carried on by other two members. Thank you, ma'am.
Yeah, please proceed.
Good afternoon, ma'am. I'll be presenting the next slide. Importance of surface preparation. Surface preparation is the most important factor affecting coating system performance. Surface conditions affecting coating life. Presence of oil or grease, presence of salt or other chemicals, presence of dust or dirt, presence of corrosion products, presence of old coatings will affect the present coating conditions. Next slide. As materials coating deposition technologies have developed and become more economically viable, more type of materials have become suitable for surface treatment. Surface modification processes are applicable to control friction, improve surface wear, corrosion resistance, and change the physical or mechanical properties of the component. The traditional methods are painting, electroplating, galvanizing, thermal, and plasma spray. Advanced coating technologies are physical vapor deposition, chemical vapor deposition, ion beam assisted deposition, ion beam mixing, and laser treatment. Next. Advances in physical and chemical vapor deposition processes and advent of direct energy techniques like electron and laser beam processes have yielded new possibilities of a wide range of coating specialization. hot-tipped zinc coatings and that provides excellent protection of steel from atmospheric corrosion to sustainably more
Okay,
advanced
last batch. Yeah, please proceed, Subramanian.
development applications such as the nanocrystalline diamond coatings that are employed in the creation of extremely hard faced cutting tools. Next will be continued by Pawan.
Yeah, kindly proceed.
One second. Afternoon, ma'am. So wear resistance, mechanical applications where the mating parts move under high loading conditions, for example, the shaft base. So there the mating surfaces will be typically coated in order to increase the hardness of the surfaces and thereby improves the wear resistance property of the equipment. So these types of parts can be highly susceptible to surface wear and damage. So if they are left unchecked, so it may lead to failure of the material due to the cracks that initiate at the surfaces of the mating parts. So generally, we employ thermal spray coating treatments in order to improve the wear resistance of the properties. So we can use chemicals like chromium nitride, nickel chromium boron, to the surfaces so that they improve the wear resistance of the material. So the surface treatments primarily employed in order to increase the wear resistance will have some added benefits of decreasing the friction between the two surfaces. And then these coatings will create an exceptional finish with a very low surface roughness value, and hence the friction between the parts will be as low as possible. And now going on to the corrosion or the oxidation resistance, and which we employ the surface treatment process is to protect the surface from corrosion when it is used in a chemically hostile environment. So the most commonly used process is the hot zinc plating process in order to protect the surface from the corrosion. And we can use some other coatings such as the thermal spray coating processes in order to improve the corrosion resistance properties of the material one. And then there are different ways to control the corrosion of the material. The altering the metal by alloying, that is, we can use highly alloyed and expensive stainless steels rather than by using a plain carbon or alloy steel. And by changing the environment, and we can control the electrochemical potential by the use of cathodic or anodic currents. And we can also use some organic or inorganic coatings corrosion of the materials. And the different methods to control the wear are we can make the relatively smooth solids to slide over other relatively smooth surfaces, and we can make the hard or the sharp substances to slide on other softer surfaces, and fatigue of the surfaces by repeated stressing fluids with or without the suspended solids to motion with respect to a solid surface. So this completes the presentation. Thank you.
Okay, so what is the knowledge you guys got after doing this work?
Uh, with surface coating, we can improve wear and corrosion resistance.
Yeah. So in what way can you just tell in simple words?
Usually when we coat the surfaces, so they improve the hardness of the materials, ma'am. So by doing that, we can improve the resistance properties, ma'am.
Yeah. So you have different surface coating techniques also. So you have to think about which is the best coating technique which is required for a particular application. So based on that, you have to go further with coating, wherein you can reduce the wear and corrosion which come usually in picture when it is in contact with the other surface with respect to the open atmosphere. Okay. So
Okay,
what
ma'am.
about the teamwork?
Yes, ma'am. We did we did all together, ma'am.
Mm. Did you refer any case studies or some research papers related to surface coating? Hello? Did you people refer any research papers or case studies?
Yes, ma'am. Yes,
No,
ma'am.
ma'am.
Okay. Was it the case study or research paper?
It's a research paper, ma'am.
Okay, okay. Which journal?
I haven't noted the name.
Okay, okay. Always try to, if you're referring the research paper, see that you refer a qualitative paper. Okay,
Okay,
so
okay.
plenty of research papers will be available. You have to try to get either the Springer publications, your Sage publication, your Elsewhere publication, your IEEE publications, where you can rely on the data what they have given. Blindly, which is available on the net, that will not fetch you any knowledge in actual, truly telling. Okay. So see that if you do something, kindly do and qualitative work. So that will really put you somewhere at the end of your all curriculums with respect to quality and with respect to the knowledge what you gain. Okay.
Yes, okay, ma'am.
Yeah, yeah. Done then. Everyone kindly take care. So we'll meet on tomorrow's class on morning 8:30 a.m. So you people don't forget to share your PPT in the Google Classroom right now, immediately.
Yes, ma'am. Yes, ma'am. Thank you,
Okay.
ma'am.
Yeah, yeah. Thank you. Have a good day. Bye
Thank
bye.
you. Thank
Bye
you.
bye bye.
Bye.